Hello, my name is Kento Sugiyama from Iowa City West High School. In this project, I developed a community-oriented flood information system using client-side web technologies. I worked with Professor Ibrahim Demir at Tulane University, formerly professor at the University of Iowa, and Dr. Carlos Arazo Ramirez at the Hydroinformatics Lab. Flooding is one of the most widespread and costly natural disasters, causing tens of billions in damage each year. With extreme weather events on the rise, these impacts are expected to grow. A flood inundation mapping system is critical for assessing flood risks and planning mitigation strategies. An example of this is the Iowa Flood Information System as shown in the bottom right figure. Existing flood inundation mapping systems have a complex pipeline involving data collection, hydrological modeling, and visualization, and rely heavily on server-side processing. These systems also have some limitations. They rely on expert-driven workflows and specialized software, which makes flood information less accessible to the public. In addition, they require significant computational power, making them time-consuming and difficult to scale. Most mapping efforts focus on specific regions of interest rather than a consistent, nationwide coverage for stakeholder engagement and effective science communication. To address these challenges, I developed the Community-Oriented Flood Information System, a nationwide, on-demand, web-based platform that makes flood risk information accessible to stakeholders, including local emergency managers, planners, and farmers. Instead of relying on cloud servers, I developed a system that leverages client-side computing directly in the browser using WebAssembly and web workers for hydrological prediction and visualization. This new system can generate flood inundation extents in almost real time using pre-computed federal datasets, such as the National Water Model. By moving computation to the client side, the system removes barriers of cost, scalability, and access to explore flood scenarios in any community in the United States. I developed the code from scratch using the JavaScript programming language. I use different libraries and datasets, for example, the Preact library. All these JSX files, they represent different components of the user interface. Under the services folder, I have all the logic for combining all the datasets in the libraries, as shown in these two rows. For example, ComID map.js houses all the compute logic for making the flood rasters. Under the styles folder, I have all the CSS, which use Tailwind CSS. Let's demo this application through a river reach in the Des Moines metropolitan area. Here we have three modes: scenario, historical, and forecast. We can set a random discharge value here to see different conditions. We can also see the time series data through this application. This dashed line represents the current date, so everything past this is all the forecasted data. Obviously, there's no flood, so it's going to be right around this 18 cubic meters per second discharge. If we set it to this date range in 2019, we see that there's a peak here at around March 15th to March 20th. So if we go back to the historical page, we can set it to that date range. And we see the flood map for that 2019 flood event. We can also click on affected structures and see the different buildings that were affected. As shown in this figure, I found that the system can predict the flood in Bellevue, Nebraska with an accuracy of 90%. This platform enables rapid web-based flood inundation mapping for all communities in the United States.